So we start out with our innate immune response. This is what you're born with, right? Later we're going to talk about adaptive, which you're also born with, but it adapts and changes over time. Where innate, right, these are the things that stay the same. You're born with these abilities. They always happen throughout your life. So the most important part of your immune system is this process of inflammation. So what we did is we just watched these two videos, and actually the animation is embedded in this lecture. I just got to go to presentation mode to get to it. But as I showed you guys how I got to my animations and videos, I have a whole link under this unit, a whole page with all the links for you guys. So the first one we watched was the leukocyte rolling. And this is probably one of my favorite ones because you actually see it. Like I said, I have no idea how they filmed this, but you actually see it happening in a mouse. So for my A&P people, how many people have taken anatomy and physiology? Right? Okay. How many of you guys have made it to anatomy and physiology 2? Have you guys done blood vessels? Or yeah, you've already had test 1, huh? That's the evil one. I got news for y'all. It took me 5 years to learn all those blood vessels, so don't feel bad if you don't know them all yet. Right? It takes time. It takes time. But speaking of blood vessels, right, we know arteries and veins are different from each other, right? Arteries, A, for away from the heart, right? They're under the greatest pressure. And also when we talk about their structure, what kind of layers do they have to them? They have a smooth muscular layer, because don't they have the ability to contract, right, and to dilate, right, to regulate blood flow? Your veins, on the other hand, can they do that? No, they don't have a musculature layer to them, right? They're very flimsy. Blood pools in them, and how does the blood actually help get out of those veins and help circulate back to the heart? What's in them? The valves, right? And then your muscles themselves, right, as you move your legs and such, help squeeze those veins and push it up past the valve, right? And then the valve closes so it doesn't fall back down. Your breathing, right? And that's why people on bed rest and stuff like that, they have those compression socks on, and nurses have to go in and move their legs and stuff for them. That's to keep their blood from pooling in their legs, right? And getting it back into circulation. So which one did they say the white blood cells crawl out of? Veins. And again, there's 2 reasons for that. It's not under the highest pressure, right? So therefore it's easier to get out, and then less layers, right? And it's actually the really small venules in your capillaries is where the white blood cells are leaving the blood, and that's the superhighway they use to travel all throughout your body, right? And they're going to leave the blood and go into the tissue. When does that happen? When do white blood cells go into your tissues? When you have infection, when you have injury, right? When they're being called there, right? Something has gone wrong in those cells, right? Those damaged cells or the bacteria themselves are releasing substances, right, that attract our cells to that area. Right? And changes have to happen in those blood vessels, as you saw, for that to happen. Right? We need those blood vessels to express those receptors so that the receptors on the white blood cells can grab on, right? Because, again, it's a superhighway. Even still in veins, blood's moving sometimes pretty quickly, right? As you guys saw, the red blood cells just flying by. Right? Those white blood cells have got to be able to attach and know exactly where they're going. Like we saw in the homing video, right? They went specifically to where they were called, right? To that site of injury. Right? This inflammatory response is very important because ultimately it is the movement of white blood cells to the area of infection or injury so that they can clean up the mess. Right? So they can gobble up, as you saw in the animation, right, by phagocytosis, those bacteria or any viruses there or any dead cells, right, from injury. And again, it's happening in one particular area, right? We want to try and contain this. If bacteria got in, do we want them getting into our bloodstream and getting on that superhighway? Definitely not, right? We want to contain this situation. So, you know, we may have injury, like a splinter. On that splinter, or even on your skin, and now that splinter has poked them through into the deeper layers, bacteria might enter, viruses might enter, and so we have to have a protection mechanism. So you have cells in that area. You have resonant macrophages, a type of white blood cell that we're going to go into more detail later, that are able to engulf invaders and alert your immune system that something bad has gotten in. As well as in the animation that we looked at, you have the mast cells, another type of white blood cell that's in your tissues and is going to express mediators, chemical signals like histamine, right, which are going to cause inflammation. They're going to cause white blood cells to come to the area. So the main white blood cells that are going to come, the name you've probably heard is the neutrophils, right? So again, a special type of white blood cells. These guys are really good at gobbling up invaders, dead tissue, and really trying to trap them into that particular area. And more macrophages are going to come, but they're called monocytes when they're in your blood. They're referred to as macrophages when they're in the tissue. They change a little bit, they differentiate. So you got all these guys that get called to this area, right? And they all traveled through your blood, for the most part, the ones we've recruited to the area to clean up the mess. In order for them to get there, what happened to that blood vessel, that venule or capillary? What'd you say? It kind of opened up, right? So notice in the animation too, fluid, right? Your blood contains a lot of water, lots of soluble proteins, a fluid phase to it, what we call plasma, right? That leaks into the tissues. So a lot of times you've experienced or seen inflammation, right? There are cardinal signs, things that we can see that happen or that we can measure when inflammation is taking place, especially when it's happening on a large scale. They are the swelling, right? And what is that from now? You know. It's those blood vessels becoming leaky and the fluid from your blood leaking into your tissues. That's why it's swelling. The redness and the heat are also linked. Because how are the white blood cells getting there? Through the blood, right? So your blood, right, looks red, right? That increased flow to that area, right? Whenever you have increased blood flow, right? Whenever you're working out and you get red, your skin gets red, you get flush, that's because you have increased blood flow to your skin, and in that purpose, it's to get rid of the heat you're generating, right, as you're metabolizing, right, as you're using a lot of energy to move those muscles when you exercise, right? It's not necessarily that your skin, right, needs more blood flow, but that's one of the ways we cool ourselves. So your blood is very hot, right? It contains most of the heat in your body that you generate. So to cool yourself off, your skin is a nice large surface area where this cooling can take place, right? And then you even start sweating sometimes so that convection can happen and you can cool even more. So my favorite example of using surface area to cool is elephants. There's two types of elephants, and you can tell them very easily one from another by the size of their ears. And that's related to the environments they live in. Right, so anybody know which one we have, Asian or African elephants at the Audubon Zoo? Asian, because their ears are what? Smaller. African elephants have those huge ears, right? And the reason for that is they pump their blood through those ears, and you'll see them fanning their ears. This is to cool them, right, because of the hot climate that they live in. Right? It's one of the ways that they cool off their blood and cool their bodies. For us, right, we have our skin. So when you see inflammation, especially near the surface of the body, right, you will see this increased blood flow, so you'll see that redness, and you'll also a lot of times feel hot because that increased blood flow. Your blood is very hot, right? It's where you store your heat. It's where you can get rid of your heat. And then again, that swelling will push against pain receptors. So sometimes you'll also experience pain. And then sometimes also, depending on the extent of the inflammation, you may have loss of function, right? If your elbow swells up real bad, you might not be able to bend your arm for a period of time. So why does this happen, though? What's the purpose? The purpose is to contain that site of damage, right? To localize the response. As we said, it's only going to go, these cells are only going to go where they're called. And those cells literally can gobble up and eliminate, hopefully destroy that invader on site. And they're going to help restore tissue function, right? Restore any damage that may have happened. Now, of course, it depends on the extent of the damage as to how long this will take place. So how do they know, right? So for our cells, their whole world is chemical and receptors, right? It's all about being able to sense their environment and respond accordingly. So you have specialized receptors on your cells. You're born with these receptors, right? And they help your cells recognize these danger signals, right? So you have toll-like receptors. That's what TLR stands for. They use lots of acronyms. I'm trying to remember if I even, see, I don't even spell them out for you guys, so you don't really need to know them. The important thing is, and what most of these acronyms stand for, is being able to detect specific danger signals. So there's these repetitive patterns that you see for some of the common things that are dangerous to us, right? So think about bacteria. What's a common substance that makes up the cell wall of bacteria? Peptidoglycan. Do you think we have receptors that detect peptidoglycan? You betcha, right? So we have these receptors on our cells. So when there's peptidoglycan present, we can detect it. Now remember, gram-negatives have an outer membrane, but the very outer leaflet of that membrane is not made of phospholipids, it's made of something else. It's abbreviated LPS, lipopolysaccharides. So again, we have receptors specifically that recognize that substance. And our cells don't have that. So the cells recognize it, right? So just like you have maybe an alarm system on your house or a dog, right? Someone tries to get into your house or yard, what do? They make a noise, right? Well, yeah, that too. The alarm goes off or the dog barks, right? My dog, God rest his soul, he was the best guard dog on earth, right? He had a specific bark for the mailman, for the UPS guy, right? Or somebody coming to visit my house. I could tell by the particular bark he was doing as to who was out there. He was the best doorbell. UPS guy and the mailman didn't care for him too much, but but he was great. You have this signal, right? And that alerts you to, okay, I need to respond in a particular way. For me, I could even tell, okay, I need to run out there and try and get the package, right? Or somebody's out there I need to let in. For your body, it's a similar thing. It's going to release chemical signals. We refer to these as cytokines. An example of one that you're probably familiar with is histamine. So they're sending out this signal, and what's going to happen? The cells are going to respond accordingly to those signals, right? We're going to get this influx of the different types of white blood cells, right? So make sure for homework, right, that you read those 2 web pages and that you comment on them by submitting through Canvas. Watch these videos again, right? Look at that other one that I mentioned, and we'll pick up here on next class.